Again, hello everyone, and welcome to our 7th webinar, Building Highly Scalable Graph-Powered Application. I just want to thank you for all being here, and I hope that you all enjoy this webinar. Our today's special guest and partner is Jasper, who will present the webinar to you and will show you how to build power graph applications with Node.js and AgensGraph. So before we get started, I just want to give you some quick notes on today's house rules. In this webinar, we will take Q&A at the end of this webinar. And for this reason, the chat channel is open during this time. And you're more than welcome to send your question to this chat box. So please send it anytime that you want, and we start answering them at the end of this webinar. Also, I just want to mention really quickly that even after this webinar, if you have any question for us, you can simply go on our website and send us a message, and we'll get back to you as soon as possible. Now, to get started, before I hand it to Jasper, I would like to introduce you to our AgensGraph team. Our teams are located in different locations. And as you can see in this map, AgensGraph team is in Santa Clara, California. We have an office in New York. We have another team in London, UK, and also another office in Seoul, South Korea. So as you can see, we are global, and we are growing strong. So if you have any question, you can reach out to any of these teams, and they will be happy to get back to you. Now, since our today's topic is building the graph application on top of AgensGraph, I would like to give you a quick review on AgensGraph and some of its features. So AgensGraph is a multi-model graph database which support relational graph, key value, and also document models all at the same time and all at the same basically storage. So, and it means that with AgensGraph, you can have a different data structure, as I mentioned, in one place, and you can start processing, analyzing, querying, and working with your data in one place. And by saying that AgensGraph is a multi-model, it will also give you the capability of writing hybrid queries, which you can work on your basically models at the same time. So what you can do, you can write, for example, a hybrid query, and you can reach out to your relational data and your graph data at the same time and start fetching your data. So as you can see in this slide, we have two way of doing this here. You can have Cypher, which is a graph language in SQL, and also you can have it the other way, which is SQL in Cypher. So as you can see in this first example, our inner query is Cypher and our outer query is SQL. So by running this, you are reaching out to both of your basically models at the same time. Or as I mentioned before, you can have it the opposite way. You can have SQL as your inner query, and you can have a Cypher as your outer query, and you can access your data. Also, as I mentioned, with AgensGraph, you can store, manage, analyze, and visualize different type of data. You can use our FDW, which stands for Foreign Data Wrapper, and you can basically import and ingest your data from different sources, which can be web data. The data can be file data, big data, and also from different databases. So you can basically transfer your data to AgensGraph and model it in a different formats and start working with your data. Also, AgensGraph has its own visualization tool, which is Agents Browser, which will give you the ability to analyze your data and visualize your data at the same time. As I mentioned at the beginning of this webinar, our today's special guest is Jasper, who is one of our great partners. Also, he is an open source veteran. Jasper is a contributor to the Spring framework, which is revolutionized enterprise Java. And he has been working with graph databases since 2016. And since then, he's been doing consulting and training internationally on graph databases topic. Previously, he was with GraphAware, and now he's doing this with his own company called Liberation Data. So I'll leave it to Jasper to introduce himself more on this if he wants. I'll be handing the webinar to Jasper now. Hi, Jasper. How are you doing today?
Hello. Yes, I'm doing very well, thanks. And thanks so much for having me. Very happy to be here. And yes, just a little bit about me. I was lucky to have a career that was worked on a lot of interesting things. As I mentioned, I've worked for the Spring framework, including on the Spring Data Neo4j project, which is a library for accessing the Neo4j graph database from the Spring framework. I founded a company with my colleague Alexi, who's here on the call with us. Hello, Alexi. And that company was all about, we developed an open source framework that powers thousands of iOS applications like audible.com and Singapore Airlines and many others. And it's called Typhoon. And during the course of running our consulting business, we were invited to create a social network for musicians and music lovers. And and in creating that application, that was my entry into the world of graph databases. So one of our team members recommended that we check out graph databases. And at the time, I didn't know so much about graph databases. And so it was a journey of discovery. And I'm just going to bring up the slides here. Uh, 1 second. And so, yes, it was a journey of discovery and getting to know about really what graph databases can do for you. And just bring up the slides. All right, here we go. And so this journey of discovery into graph databases commenced, and I want to share a little bit about that discovery process. So if you've not dealt with the graph database before, it doesn't mean charts, graphs like these. So that's not a graph database. Basically, a graph database is it comes from the field of mathematics called graph theory, and graph theory was started by a mathematician called Leonhard Euler, and Leonhard Euler was a prolific intellectual. He contributed to mathematics, physics, astronomy. He was a musician, and during the course of his career, at one stage, he lived in a town named Königsberg. And in that town, there were 7 bridges. And I'm not sure why, but maybe it was a family fun day, or maybe it was a drinking game with his buddies. But what they wanted to do was to figure out if in that town where there were 7 bridges, if they could cross each bridge once and only once. And being a mathematician, he distilled down that problem. And so he took the town, and then he got rid of the superfluous information, and it turned out to be this. And then he distilled it down further, and this is what we call essentially a graph. And so this was the start of the field of graph theory in the branch of mathematics called combinatorics. And so essentially these were the land masses and these were the bridges. And he went on to discover that there needed to be an even number of bridges, and there's something in graph theory called the degree, and it turns out that the degree of what we call a vertex or a node is important. So the degree had to be there had to be exactly 0 or 2 nodes of an odd degree in order to cross each bridge once and only once. So what does that have to do with graph databases? With a graph database, information is stored in this network structure. So if you go back and you look at a traditional relational database, we have information stored in tables, and that came from the digital transformation in the early days, where we needed to digitize paper-based processes consisting of rows, and relational databases did a good job. However, in today's landscape, we have data that has a very fluid structure. So if you joined the webinar early, it talks about 80% of data in present enterprise is not structured in a way that's easy to model in a relational database. So if you talk about, for example, a product catalog, you can have a parent category called apparel, and then you break down these products. And as you go through this tree structure, you have specifics and properties that are related to a deeply nested data that don't necessarily are not necessarily shared by peers on another branch of that tree. So this kind of information is perfect to model in a network, and not so good for a relational database. And so what do graph databases do better? The graph databases allow you to store information in a network structure, and they allow you to query deeply nested data, so they're very good at pathfinding. On some graph databases, you can look up the starting point of an area of interest and then traverse through that network. So every node and edge on your graph database has a key value store associated with it, and you can traverse that on AgensGraph. You can do that in what's called O log n time complexity, which is given that AgensGraph is a native database, it can be very capable and performant. Another thing that graph databases do very well is that if you look at computing science algorithms, much of the computing science algorithms that we have, that we employ on a day-to-day basis, are actually working with network structures or working with graphs. So if the data is already in that format, we can apply those algorithms. To give you an example of that, let me name a few companies like Twitter or Facebook or Google, and each of these companies employ graph algorithms in order to meet their customers' needs. So in the case of Google, the PageRank algorithm is based on a graph concept called centrality, specifically eigenvector centrality. So you can apply, the data is already in a format that you can apply graph algorithms. And finally, network structures or graphs are very fluid. And if you have a database that has transactions and allows you to execute transactionally. I've just got a request here to annotate the content. Go ahead. If you have a database that allows you to employ transactions, so in a database, we have the concept of an ACID database that gives you a set of operations, and they either all have to be successful or they're all rolled back. That allows you to have this fluid network structure that can evolve in predictable steps, and that's very, very powerful. So essentially, that's a quick summary of the opportunities for employing graph databases. And where's this? So today's talk is about building highly scalable graph-powered applications with Node.js and TypeScript. And before we begin on that topic, I just want to touch on some of the strengths and weaknesses of Node.js and the evolution. So Node.js came on the scene a few years ago, and people were really responded to it because it allowed you to write fast applications. It was quite scalable and to be productive very quickly. And in the early days of Node.js, code would sometimes look like this, not very nice. And that's because it was utilized a lot of callbacks. And then that was addressed by promises, and then the more recently the async await syntax, which is essentially the do notation of promises from Haskell. And finally, in the last year or two, there's been a lot of effort to employ architectural patterns on Node.js applications. So there's frameworks like Nest.js, for example, that help you to structure your code in a way that's very coherent and easy to reason about. So Node.js is now becoming more of a mature platform for developing applications. So today I want to show you how to build highly scalable applications that are graph powered with Node.js at the same time as being able to benefit from a cohesive, intelligent architecture. What happened? I've just got a problem here with the slides. I can draw beautiful pictures on the screen, but I'm not sure how to present the next slide. Just bear with me for a second. Okay. All right. So that's Node.js, and in order to build these scalable graph applications that I mentioned, I'd like to introduce a new framework, and it's called Dravine. And Dravine is a library for building graph-powered applications. There's a website, so if you want to visit the website, it's called dravine.org. And on the website details essentially about the driver. Dravine stands for the Divine Driver. The reason it's called the Divine Driver is because it helps you to obtain supernatural graph database powers. So what do we mean by supernatural? Well, any magic sufficiently advanced is indistinguishable from technology. So really, it's just a few clever technology ideas that help you to be successful. And when you have a typical graph database driver, it deals with a level of abstraction that there's a fair amount of manual work that's entailed. Dravine takes care of these manual tasks for you, so it manages infrastructure concerns such as obtaining and releasing connections and sessions. It facilitates the implementation of repositories. And then repositories can be used to implement what we call services. So we'll look into that what repositories are about in more detail as we proceed. It supports declarative transactions, it supports streaming, and it helps you to map your query results to and from the graph structure onto typed entities. So if you follow along on the website with me, you'll see here that there's a connection management, and basically the connection manager is your entry into the into being able to query your graph database. So it's got a set of methods here that you can use, and it's the job of the persistence manager to take care of the boilerplate, such as obtaining a connection and using details that are registered when the library is bootstrapped. So actually, let's go ahead and do that now. So if you are also on the website, if you scroll down a little, and you can see there's a sample application, and in the sample application there's a link to a repository here. So we're going to go and grab that repository. We can clone it, and here I have it here. And after we clone it, we'll just run a npm install to set it up. And while it's doing that, I'm going to go ahead and start AgensGraph. So if this is your first encounter with AgensGraph, it's a pretty fun installation. You actually build it from source yourself. Sounds a little bit daunting, but it's actually very simple. There's guides on the website on how to do it, and if you have any trouble, you just reach out to the community and they can help you build it. It uses a tool called CMake, which is a Linux build tool. And so we're not going to build it during this webinar, but it's already built here. So I'll go ahead and start the database. So now I can see the database is running, and I've installed dependencies here. And so what we can do now is to open up the project with our favorite editor. I like WebStorm, which is from IntelliJ. Being a polyglot programmer, it's a really nice tool to be able to switch between different programming languages and have all the same keyboard shortcuts and those kinds of things available. So what we do here, when to get started, there's a environment sample, and we talked about registering database details. So here we've got a sample, and we're just going to go ahead and copy that over to a .m file and fill in the details of the database that we created. And oh, by the way, before you run the sample, there's a gist here that is linked, and this data set comes from a blog here on the Liberation Data website called Rock and Roll Traffic Routing. And essentially it's a set of traffic routes through a fictional city, which is part Metro Manila, part Coney Island, and part Paris. And in the blog, you can have all kinds of adventures in this fictional city and learn about graph databases as you go. So you may want to try that out. But in the meantime, we can go ahead and just run this gist and load that into the database. So I'm going to open up the PL SQL tool, and we can start looking at the data. So I've got this database called traffic, and the query language for AgensGraph is called Cypher. So we can query. So I'm just going to. So this is just a simple query. And actually, before you do any queries, you should set the graph path. And so we can see that this data set is loaded up. We've got 23 vertices registered in the database. So now we've got this end file pointing at the running database. And the other thing that we do is just in the context of our Nest.js application is import the Divine module, and we give it a list of connections. We'll just have one connection, the default, and we'll tell it to build or resolve from that environment. There's a few different ways to set up your connections, but this is the easiest. Optionally, your connection can be named if you've got multiple, but in this case, we'll just use the default. And so now we've bootstrapped Divine, and as it says on the website there, we can then go ahead and use our persistence manager interface to implement repositories. So there's a simple repository here called a health repository, and using composition, we inject this non-transactional persistence manager, and now we can implement a repository. And so that brings us into the topic of repositories. And basically, to discover about what repositories are, we're going to return back to the Divine website and read about it there. So essentially, repositories are a common pattern of structuring object-oriented code to adhere to single responsibility principle, and they let you group your database operations for a particular type of entity or thing that you're querying. When I say entity, I mean this is something in your domain, and when I say domain, this is when you use graph databases to solve business problems, you start creating models. And so if I'm creating a graph database to do traffic routing, my domain will be about having roads and cities and towns and suburbs and those kinds of things. So we can logically group the database operations, and this allows you to use repositories. Repositories are a powerful way of keeping your code adhered to single responsibility principle, and they also give the opportunity to, you can even swap out one approach of one database for another, for example. So they're a powerful technique. So we've got this repository here, and we'll just go ahead and we'll run the test case. And this particular Mac's a little bit slow. I'm using this one because it works better for WebEx. And so you can see here that when it runs, it will log the details for you, and the elapsed time, and give you some details. And the result finally here is printed to the console. So now I can use this repository to build up what we call services. But before we talk about services, I want to talk about transactions. And so in order to, well, actually I will talk a little bit about services now. I wanted to let you know that you can use repositories to in the same way that you can use composition to use your persistence manager to build repositories. You can assemble services from one or more repositories to meet some kind of business goal or process. So an example would be a transfer service where you transferring funds from one Bitcoin account to another Bitcoin account. And this is where transactions come into it. So when you execute this transfer, if you withdraw funds from a source account, and you deposit funds in a target account, and the target account ID is not valid, you want the whole transaction to be rolled back so that the information is back in a clean state. So when it comes to transactions, with a traditional driver, you will spell out each of these steps. So you'll obtain a connection, and then you'll start a transaction. You'll perform a sequence of tasks, and then you'll either commit or roll back. This is great, but well, actually, it's not so great because your code is taking on many concerns simultaneously. And when we write highly structured code, we want the code to be easy to reason about. So we want to be able to have code that is focusing on doing one thing. So, for example, a code that's specifically just about transferring funds from a source account to a destination account. And with regards to transactions, that can be a little bit tricky because here on the Divine website, I talk about transactions. When we analyze transactions, they fall under what is known as a cross-cutting concern. And they're called that because they're required in many places, or in other words, they cut across many modules. And these kind of requirements don't fit well with pure object-oriented programming because they compromise efforts to adhere to SRP. So to give an example, imagine that you're implementing this funds transfer, and then you need to add transaction behaviors, and then some security concerns, and then audit. And before too long, you had your class that wanted to represent one single responsibility or role has now become kind of a bit of a mess and difficult to reason about. And so these kind of cross-cutting concerns we can identify in requirements because we hear the word whenever or every time. Every time we need to deal with an endpoint in our system, it needs to be transactional. So that's identified as a cross-cutting concern. Fortunately, that can easily be modularized in TypeScript using decorators, and decorators are a kind of higher order function that wraps the original function and returns the original function with the transactional concerns applied. And so to run transactionally, all we need to do now is just apply this decorator, and what will happen is if there's an existing transaction, it will participate in that transaction. Otherwise, it will start one. So this is a powerful way of, if you look at the funds transfer example, we can have a transactional endpoint that withdraws funds from an account, and we can have a transactional method that deposits funds in an account, and we can use those in their own right as reusable method. And then by using composition, we can use that within one method that encompasses those two operations. And the way that works is that in the context of a web app, you register this transactional middleware in the Divine library, and then each individual request will be transactional. By default, they'll have a transaction propagation. So we can see here on the website, there's different kinds of propagation. The default is to required, which means to participate in the running transaction. Otherwise, start one if one doesn't exist. So in this case of a transfer, it'll withdraw the funds, and then if the target account ID is invalid, it won't leave this poor account with the missing money. It will roll back the whole transaction. And if it is valid, when the outermost transactional method completes, the transaction will be committed. So the important thing to note here is that we're just using regular control flow where we don't have to worry about accidentally forgetting to commit the transaction or to roll it back. We just throw normal errors, and the library takes care of care of the details for you. So it manages that boilerplate code. So just to recap, using the transaction decorator, we're able to implement transactional services. And if there's any questions about what we've covered so far, please feel free to type them in, and we can address them as we when we get to the question time. On the website, the next thing I talk about is streaming, but I'm going to skip over that, and we're going to come back to that. I want to touch on object mapping, and so I'm not sure if how many people in the audience have used something called an ORM tool or an OGM tool. But basically, these are tools that allow you to write to work with a persistence or work with a database, such as a graph database or a relational database. And they can be powerful, but there's a few things that when you're writing a highly scalable application to be wary of. And so Divine, in order to meet its goal of optimal performance, takes a slightly different approach to a typical OGM or ORM tool. So I just want to review with you how a typical ORM or OGM tool would approach the problem, and then and talk about what Divine does differently. So in a typical ORM, we define a generalized set of entities, and that is basically a network of classes that represent things in our domain. So it could be passengers and airlines, it could be bank accounts, it could be traffic routes, and we have instances of these domain objects loaded by our OGM tool, and the queries are executed for us on our behalf. And then having loaded these instances, given a specific use case, we then pluck pieces of information from these entities and map them onto a response object, and that gets marshaled off and packaged up. And this approach can work, but as I mentioned just now, when it comes to highly scalable applications, some problems are entailed. The first is that there's an overhead to the mapping, both in terms of the implementation effort as well as the runtime performance cost. Secondly, because the queries are system generated, there's really just a limited opportunity, or it's not easy to undertake performance tuning, and or to use sophisticated locking for a special scenario, or any of these kinds of things that you might encounter on a highly demanding app that needs to process a lot of data and handle flexible use cases. Similarly, because these entities are generated, it's not really very likely that they'll be the ideal structure for one specific use case. And finally, one of the main benefits of having generalized entities, unfortunately, is often rarely realized with ORM or OGM tools in any case. The main benefit would to have a rich set of generalized entities with rich expressive methods. What we often end up with is the anemic domain model anti-pattern, which Martin Fowler writes about. If you're interested, you can read about it on the website. In the article, he says that he's not sure of the cause. In my opinion, the cause is that in order to have a rich set of expressive behaviors, your entities will need collaborating objects to help them do their job. And the way that they would be able to do that is to have dependencies injected. So most OGM or ORM tools don't offer to help initialize your object with services that could help them do rich or expressive jobs. So they end up being just holders of data. So whatever the cause, it doesn't really address the first several problems. That is that they're not easy to performance tune, and they're not highly adapted to a specific use case. So what I recommend with Dravine is another approach, and that is that you create a query for a given use case, and you have the opportunity to performance tune that query. So if we scroll down onto the website, basically we bootstrap the app, we define our own custom queries, and then we implement repositories. So, and then the query itself is injected with a decorator. So if we go back to the sample here, and we look at the route repository, we've got this custom query that we can work with here. And when you're writing a highly scalable application, you write queries for a given use case. So in a graph application, we have this underlying graph, and we're going to project a subgraph for a given use case. So we're going to pluck things out of the graph and structure the information in just the way that we need it. And the beauty of the Cypher language is that we can do that in a very expressive way. And because graph database engines have been evolving for either they'll leverage an existing database engine, which is very, very mature, or a lot of R&D has gone into creating an engine that's runs very efficiently. You can write queries that will be highly performant, and you can profile this query separately. You can run it and test it. It's fully unit testable, so you can run it from within the IDE or wherever you need to. And once you're happy with it, you just go ahead and inject it in your repository using a decorator, and then we can go ahead and use it to implement repository methods. So if I want to find the fastest route between a start and a destination, I just write a query specification here where I use that statement. I can bind some parameters. I limit the results just to one result. And then finally on the mapping here, I transform it onto a typed object. So here's an example of the typed object, and it uses the class transformer library to do the mapping for us. So I can map field names from one to the other. I can map enums onto enum types. On the website, there's an example of showing you significant sites along the way. So if you have nested data, you can have a nested object in here. And so that's a way of getting the best of both worlds. You can have cleanly structured code, and you can have highly performant code, and queries that can be unit tested and evolve as your requirements evolve. Besides using this transform method, you can also, for example, if you wanted to, you could map the object yourself and do a manual mapping. Or if you wanted to, you can just return a plain object of JavaScript type any and return the raw object itself. But in general, for most cases, it's you can transform onto this typed entity, and that's how it works. So that next topic that I want to talk about is streaming. And for streaming, we have a picture of a cow. You may be wondering why. I shall explain. So we've covered that we can assemble transactional repositories and create services from an aggregate of repositories. When it comes to streaming, for some use cases, we might have data that's too large to be buffered in a single result set. And So if you have a query that returns, 30,000 results, you're going to have problems if you try to buffer that in a single result. You can have, out of memory errors, and your application could be crashing. So the way to solve that is that fortunately the persistence manager has the ability to open a cursor, and a cursor is generic, so you can open a cursor for a given type of thing. For example, this find the routes between a start and a destination will give you a cursor for a route object. And cursors provide two mechanisms for streaming. The first is that they're asynchronously iterable. And so in ES 2018, we can use the for await of statement. And what this means is that you open a cursor, and then it will fetch information in batches and consume that information until the upstream is depleted. So we go back to our route repository here, and we look at the streaming version of that, where we're opening a cursor here, and there's this optional batch size parameter. The default for this is 100. You can put whatever you like here. Because we've got a fairly small data set, I've put a fairly contrived value of 5 in here. So I'm going to go and look at the route repository spec in the sample application and run it. And while it's running, as you can see, it will execute the query to read in batches and keep on advancing the cursor in steps. So it reads a set of 5, and then it reads another set of 5. This, to the end user, this just looks like you're iterating over a normal iterable. However, behind the scenes, asynchronously, it's pulling new results down whenever needed until there's no more results. So that's great. But now we get to why we have a picture of a cow on this slide. And while I was building Dravine, I saw a fella on Twitter said that whenever he sees a cow, he doesn't see a cow. He must be an engineer because rather than a cow, he sees a stream. So there's grass goes in one end, and then there's several asynchronous processes going in the middle, and then milk comes out the other end. And that got me thinking a little bit as well. And actually, I thought, wow, the cow's telling us something because so in some religions how cows are very revered. So I was revering the cow here because it actually tells you how to do streaming correctly with Node.js. So if we look at this asynchronous iteration example, it looks really cool, but if we loop over a set of results and push that information into a file stream, for example, or any kind of stream, we can actually push that information in too quickly. So just like with the cow, you don't shove grass into your cow, you actually milk the cow, and the cow will go ahead and eat whenever it's hungry. So the same applies in Node.js, that you don't shove information into a stream, because see here how we're returning result. If you push information in too quickly, this will actually return false at some point, and that's it's basically a warning that the buffers are overflowing, and if you keep doing this, your application can actually crash. Or I've actually seen it during some testing for Dravine. Worse than crashing is that it can start dropping rows, which is not a good situation because you don't want to be going unpredictably losing data. So the solution is, what we can do is we just take our cursor and we ask it to be a stream. And now that our cursor is a readable stream, we can pipe it as many times as we like into another stream. So you can set up these pipelines where you have these flows, and the information will flow through at the speed that the sync stream can handle. So this is called Node.js's back pressure system. And there's an example of this in the sample. So the second one here, which I'll run. So we're just telling our cursor to be a stream here. Optionally, we can since it's a common operation, we can specify a transform at this point. And then after we do transform, we pipe it into the file stream. And now all we have to do is tell the file stream to go ahead and pull that information through. And so we won't have any out of memory problems. We'll be efficient. It'll be nicely performant. And we can process very large information, large volumes of information successfully. So that's that. I guess we'll just let it run. So you can see here it's still pulling through in batches, but this time we wouldn't overload our file stream if we, by pushing information in, we let it be pulled through. And the final topic that I wanted to present to you today is testing. So this is an idea based on the Spring framework. It's a Java framework. And in that framework, you can run your tests inside what we call a rollback transaction. So if you have shared data or your tests are running concurrently, you can execute a sequence of operations. And because database transactions give you a read isolation where inside a transaction you can read uncommitted data, you can go ahead and make assertions that your application is doing what you expect it to do. And then finally, at the end of that test, everything will be rolled back. So there's again, there's some examples of that in the sample application. And if we did, the way that you use this is just to inside your test to say in test context run, and then anything inside here will be rolled back. During troubleshooting, if you did want to go and see what happened inside the database, you can just specify that you don't want it to actually roll back, and then you can go and use your database tool to investigate exactly what happened. And so that's everything I wanted to present to you today. Just to recap, Dravine is a library that lets you connect to a graph database and build highly scalable applications. It lets you build your applications that adhere to common, well understood object-oriented and a smattering of functional programming paradigms. So you can structure your application in a clean, well-architected way, and it'll take care of all those infrastructure concerns and boilerplate code and handle that for you. So you just write business-oriented code, and it supports large amounts of data. You can use streaming to handle large volumes of data in a timely and efficient way. And it's got a few object to graph mapping tools, but because of its goal of optimal performance, we recommend that you write use case specific queries and that you take care of the performance tuning. It's really, with a little bit of practice, you can write Cypher queries that are highly performant, and to get the best out of your graph database, that we recommend that you do learn how to write queries rather than use a tool that kind of abstracts that away for you. And I've been using these approaches for many years now on several production applications, so it's battle tested. Basically, there was a lot of blood, sweat, and tears that went into implementing this. There's a lot of learning experience. So the reason that I built this is I wanted to help people to be successful and basically to be able to leverage some of the experience that I had over the years and try to be successful from day one. So that's the application, the library, and feel free now to ask questions.
Thank you, Jasper. Thank you for the presentation. So as Jasper mentioned, now the Q&A is open. So we'll give it a couple minutes. So if you have any question, please send it through the chat box, and we'll start answering it in a couple minutes. Okay, so let's check to see what questions do we have so far. Okay, looks like we do not have any questions so far. But again, if you have any question, you're more than welcome to reach out to us. And actually, the questions are coming, so if you give me 1 second. So the first question which we have here is that, is there, Jasper, some library you can recommend for the front end?
Front end, depends what you want to do. So a general purpose library, I particularly like myself, Vue. But if you're looking at data visualization, it depends whether you want to pay for the product or you want to use an open source product. So do you have some specific needs in mind? If you, for general purpose, it really, my personal favorites are Vue, Angular 2 Plus, and React.
Angular and React. Thank you, Jasper. Yes, so he said general purposes for the web app. Great. Yeah. Okay, another question that we have here is that how big was the data size?
In this particular sample application, it's just a contrived set of I think it's 23 nodes and 50 edges. Um, but you can use AgensGraph to scale to very large data sets. Um, when you have the reason that AgensGraph performs well is that first of all, it's built on the Postgres engine, which is 20 years old and it's been around for a long time, and so a lot of research and development went into making that a mature and stable platform. Some graph databases let you look up the starting point in a graph and then traverse the neighborhood in what we call O1 time complexity. That means the neighbors in the graph are stored inside a linked list, and um, that's powerful. The approach that AgensGraph takes is to leverage Postgres index, which is a capable index. It's a bitry index, and you can, in practice, it's very performant, and you can use large data sets. Usually, the whole graph will fit into RAM, and so it's usually some RAM lookups. And one case where it does perform particularly well is on what we call supernodes. So when we have a supernode, it has an index lookup that's very fast. And a supernode is a node with a lot of edges.
Okay, thank you, Jasper. So we are running out of time, and if we didn't answer your questions, we'll get back to you as soon as possible. And feel free again to send us any question that you have. And I just want to thank you all again for your participation, and we hope that you enjoyed this webinar. And thank you, everyone. Have a great day. Thank you, Jasper.
Thank you.